And urine maybe too. If you want maybe,
Yeah, that's fine.
because I'm gonna have one after. Yeah.
So, how much milk? Saliva?
1 ml is okay. Milk, yeah, 200 microliters. I think we try to save other places can better results. Or we already contacted all third. Your background.
With a science couple. And we'll start with, of course, the lioness of the team. And that is Elizabeth Yuriev, who was born in the Ukraine and went to school in Kharkov in undergraduate as chemistry. Her most productive achievements include a 10-year-old child who is not with us tonight, but is traveling with them. And so I'd like you to welcome Elizabeth.
Thank you. Thanks. I would like to start by thanking German for discovering us. When he came across this book, he decided that he would like to invite us to come here, which was a very timely invitation because we were planning a trip to the US around this time. And thanks for David to inviting us officially to present at this gathering. So my title is Sugar Footprints in the Snow. I was thinking mid-October, maybe there will be snow already, but I've been quite happy just to see the full foliage rather than snow. But I will talk, there will be a bit of a connection with the snow, but I will talk about mapping of carbohydrate protein interactions in silico, because my main tool, the thing that drives my research, is molecular modeling. And carbohydrate protein interaction is one of the applications of that tool. I will talk a little bit about where we're from. So a few people were asking us where we are. So you guys somewhere around here. And we didn't fly this way. We flew sort of behind this map. From here, that's Australia. That's home. And polyclonal, that's what we believe. That's how polyclonal response works. You've got a bunch of monoclonals, and they all recognize the same epitope, but they do it differently, and therefore creating more strains in that recognition. We also looked at range of conformations within that nest of different docked poses, and that's where we had an opportunity to compare into NMR results. So in this particular case, the black line represents our results.
So you compared glide and autodoc, and you saw that glide works better. But autodoc assigns charges to the carbohydrates
Yes.
by gap.
Yep.
And how
We
does-
used OPLS charges.
You use what?
OPLS charges, which is a standard charge.
In both. So you use the same population.
Yes, yes, but you can vary. We just started with default.
So you did, but you didn't use the one provided by the program, by the software. You had the
No,
same
glide is part of Schrödinger, and Schrödinger can assign charges, different ones.
Yeah.
We used OPLS for still
in
charge.
glide.
We have, born in Sydney, Australia, studying evolutionary biology, found his way into studying the variable genes of chronic leukemia. Here is the crystallography part that she's been knocking all night. Let's see what it looks like.
Thanks, David. Thanks for the invitation again, German and David, to visit Boston at the end of our vacation. So I'm just trying to struggle out of vacation mode and get back into work, which I know was piled up at home for me. My work is really looking at the structural glycobiology, I guess, of antibody interactions with host and pathogens. And sometimes we divert into other systems, but generally I'll just talk about Some observations we've made over the years with antibody structure, from crystal structures of fragments of antibodies to solution structures of the intact antibodies, and how the carbohydrates or the glycosylated part of that protein could be influencing conformation and dynamics of the protein using experimental techniques known as So, briefly introduce the research institute that I come from. It's the Burnett Institute. Macfarlane Burnett is the patron of the institute, and he was an immunologist that got the Nobel Prize in Australia, brought together initially just a model to illustrate what we're trying to do with this system. So here in the intact antibody, we just modeled the crystallographic structure of the FAB and the crystallographic structure of the FC, this antibody, through this region called the hinge region. This hinge region varies between different subclasses.
It used to be said that the actual geometry was very, had to be very precise for good carbohydrate binding. Is that still true?
We need to define good carbohydrate binding.
High affinity, is that what we're calling it?
Yeah. Or avidity.
There's quite a flurry of discussion about 2326. There's a lot of people with very strong feelings about that.
Yes.
Very strong feelings.
You flew around there.
It's certainly something we need to examine in terms of these structures.